Let us deal with some terminology of shrinkage. This one is based on the definitions of TML, one of the brand for the shrinkage. If you are using the other brand, the terminology might differ slightly. You can always refer to their catalog or their product descriptions for more detailed information. Since my main references are based on TML, we shall look into it one by one and gain better understanding on strain gauges. First, it will be the gauge type. It is referring to a group of gauge models that have the same structure, configurations, and characteristics. The second, it will be the lot. It is referring to a group of strain gauge that have the same sensitive element made of the same alloy ingot. The sensitive elements is referring to the foil or the wire, which in this case here, it is made of the same alloy ingot, and they are manufactured using the same mechanical and heating procedure and have the same characteristics. Next, it will be the batch. It is a group of strain gauge of the same type in the same lot that were manufactured at the same time under identical conditions. The figure here shows the relationship between the gauge type, lot, and batch. When we talk about the gauge type, we are talking about a type of strain gauge cover a broader context. This gauge type will determine the applications of the strain gauge. Now the lot here is the subset of the gauge type. This one is more referring to the specifications of the strain gauge. What type of sensitive element being used, how it is produced, what are the characteristics of the strain gauge. Narrow down further, it will be the badges. This is referring to the strain gauge manufactured at different time under different conditions. And then, where do you see this information? This is normally found on the package of the strain gauge. The specifications are given here. This is referring to the type, this is referring to the lot, and this is referring to the batch. By having these informations, you are able to trace the origins of the strain gauge. You see the coding for the type here. This carry informations. We will discuss on this in future in our following videos. As far as you need to know for now, this product have their own definitions in terms of the gauge type, lot, and badges. Next, let us look at different types of strain gauge. We have uni-axial strain gauge and multi-axial strain gauge. This is a typical uni-axial strain gauge. It is designed to measure strength in one direction. This will be the directions that the strain gauge is measuring. As for the multi-axial strain gauge, it can be used to measure strength in two or more directions. These are multi-axial strain gauges. This is 2-axial strain gauge and 3-axial strain gauge. Now you have 2 strain gauge as one piece, and here you have 3 strain gauges in one piece. For this multi-axial strain gauge, you are measuring the strength in the perpendicular directions. As for this one, you are measuring the strength in the horizontal, vertical, and diagonal direction. This shrinkage can come in pieces, or if you really need to measure strength in various directions, you can combine several shrinkage, which is uni-axial, arranged in this manner, or this manner, or this manner. This can be done by using uni-axial shrinkage. This is conditional to careful installations of the shrinkage. You know that the shrinkage is very fragile. If you don't handle it with care, you may damage the shrinkage. Imagine that you need to use this multi-axial shrinkage. You have accidentally detached one of these gauge lid. This will lead to a situation that this shrinkage is not functional. Then you lose the data here. Now, among the multi-axial shrinkage, it can be further classified into staggered type and the plain type gauges. These are the staggered type strain gauges. The sensitive elements are laid one over another, and the center of all the grids are vertically aligned. Remember, we mentioned about the measurement axis. The center here will be the exact locations that you are measuring. Now, staggered type of strain gauge has this center overlay one over another, only at different directions. Another type, it will be the plain type strain gauge. The sensitive elements are not overlaying each other. There is no contact between the sensitive element. The measurements will be based on this point here. You are measuring the elongations or the strength, which refers to this point in these directions, and this direction. To be more specific, although it is placed at this point here, what you are actually measuring is the elongations at this point, at this point, and at this point. To determine the exact locations, you will need to refer to the measurement axis for every single strain gauge. These are the measurement axis for this strain gauge. This is meant for this strain gauge, and this is meant for this strain gauge. As for the staggered type strain gauge, the measurement axis, it will be something like this. Now the next question is, which type of strain gauge is suitable for your case? If you only need to measure strength in one direction, for example, you are measuring the elongations of a steel bar, then you only need uni-axial strain gauge. But if you need to measure a plate which is subjected to forces in various directions, you are expecting the strength goes in more than one directions, then you may use the multi-axial strain gauge. Now for the multi-axial strain gauge, you will need to determine which type of strain gauge you are using, depending on the situations. If you are measuring an exact point in various directions, probably the staggered type of strain gauge will be more suitable. But if you are measuring a regional type of strength with reference to one specific point, then you may consider to use the plain type of strain gauge. Next, we talk about the ordinary gauge and integral lead wire gauges. What does it mean by ordinary gauge? That means the strain gauge come along without any wire. As for the integral lead wire gauge, That means the shrinkage come together with the lead wire. You know that ultimately, shrinkage will need to be installed onto the test specimen and then connected to the data logger. Now, if it comes without any lead wire, you will need to do some soldering and connecting the wire to the shrinkage. This wire shall eventually be connected to the data logger. Now, how do you connect the wire with the shrinkage? You will need a connecting terminal, which looks something like this. Solder the gauge lead onto the connecting terminal at one end, and then solder the wire on the other end of the terminal so that the current can pass through the wire to the shrinkage and then going back. This completes a circuit, and then later this wire is connected to the data logger. Now, if you use the shrinkage with integral lead wire, the wire is connected to the shrinkage as the final product. Normally, the wire is long enough for you to connect to the data logger. The wire can be 1 meter, 3 meter, or 5 meter long. There are two types of lead wire here. This one is 2 wire and this one is 3 wires. In terms of the terminal, I believe it makes no difference between the 2 wires and 3 wires, as shrinkage only have 2 terminals. Normally, the longer the wire will come in the form of 3 wire, as it is stronger.